Rumors from the supply chain confirm a massive, unprecedented order for linear actuators, the key component, proving Tesla's true timeline for humanoid mass production. That sentence lands with a weight that silences the room. It feels less like a corporate announcement, and more like a secret that has finally broken free into the open air. It is a story that begins not with a flashy presentation, but with a quiet detail hidden within the vast, interconnected network of global manufacturing. The focus is on a seemingly simple part: a linear actuator. These are not the glamorous, headline-grabbing components, but they are the functional heart of modern robotics. The mechanical muscles that provide precise, straight-line motion. These components are essential for a humanoid robot to perform tasks like gripping, lifting, and walking with stability. When a company, especially one as closely watched as Tesla, places an order for these parts, in quantities that dwarf typical industry needs, it signals a profound shift in strategy. It suggests a move from the experimental phase of research and development into the concrete, demanding world of mass production. This single piece of information, a leaked purchase order, has the power to reshape expectations. For those who follow Tesla's every move, it is a critical piece of the puzzle. So, what exactly is the actuator leak? At its core, it is a set of documents purportedly from a key supplier in Tesla's manufacturing network that have surfaced online. These papers are not filled with dramatic prose. They are technical, filled with part numbers, delivery dates, and, most importantly, order quantities. The specifications for the linear actuators described align perfectly with the known design requirements for Tesla's Optimus robot, particularly the newer, more production-ready versions. The numbers are staggering, far exceeding what would be needed for simple testing or small-batch pilot programs. They point squarely toward a company gearing up for a full-scale production run. The delivery windows for these massive shipments of actuators are concentrated in the months leading directly up to the first quarter of 2026. In manufacturing, you order components to arrive just in time for when you plan to start building the final product. This tight scheduling minimizes storage costs and ensures the parts are ready for the assembly line. For supply chain watchers, this fits a recognizable pattern. When leaked documents align with public statements and known design changes, rumor becomes a highly probable event. Tesla has publicly stated it aims to begin mass production of the Optimus robot in the first quarter of 2026. For a long time, many observers were skeptical. Building a functional, reliable, and affordable humanoid robot is one of the greatest engineering challenges of our time. Given Tesla's history of setting ambitious, sometimes unachievable deadlines, many dismiss the Q1 2026 goal as aspirational marketing. However, the recent leak of the actuator orders fundamentally changes this perception, providing a tangible link between public declarations and private operational planning. Ordering components on this scale involves significant financial commitments and complex logistical coordination. A company does not place such an order unless it has a high degree of confidence that its assembly lines will be ready to receive and use those parts. The leak transforms the Q1 2026 target from a hopeful projection into a believable, data-backed operational goal. This specific date matters because it acts as a clear marker for the entire industry, a timeline against which all other efforts in humanoid robotics will be measured. Q1 2026 is not just a deadline for Tesla, it is a starting gun for a new technological race. Hitting this target would demonstrate that practical, useful humanoid robots are an imminent reality. The believability of the Q1 2026 timeline is not just based on the actuator leak, it is also supported by the evolution of the robot's design, specifically the Optimus V3. Since the first somewhat clumsy unveiling, Tesla has made significant and rapid progress, each iteration lighter, faster, and more capable. V3 appears heavily focused on manufacturability. By standardizing components across different joints and limbs, Tesla can streamline its supply chain, reduce assembly complexity, and lower bottleneck risk. The V3 is also designed to be more robust, ensuring minimal maintenance in real-world factory environments. Central to V3 are the very actuators in the supply chain leak: more powerful, more efficient, and easier to manufacture at scale. By bringing key components in-house, Tesla gains tighter control over performance, cost, and supply. The challenge is now building robots in hours, not weeks, with every unit meeting the same high standards. V3 is a machine designed not just to perform tasks, but to be built by the thousands, a bridge between a bold idea and a commercial product. Imagine a car factory today. It is a marvel of automation, massive stationary robotic arms welding, painting and lifting with incredible precision. These robots are powerful but rigid, bolted to the floor, programmed for a single task. Now picture that same factory populated with teams of Optimus V3 robots. These humanoid machines are not fixed in place. They can walk from station to station, fetch parts, and perform final quality checks. As an example, assembling dashboards Monday, loading doors Tuesday, assisting wiring Wednesday, all via a simple software update. Factories become more dynamic and adaptable, reconfigurable workspaces that respond quickly to demand. In warehouses, fleets of Optimus robots could navigate aisles, retrieve items, and transport them to packing stations, working around the clock. They reduce strain on human workers, speed up delivery times, and handle varied package sizes without reprogramming. The holy grail of logistics. Humans shift to managing the fleet, troubleshooting issues, and overseeing the flow. The goal is not just efficiency, but safer, healthier workplaces. Consider the physical toll of lifting hundreds of boxes per shift. Imagine a robot taking that burden so people can do higher value, less punishing work. The prospect of mass-produced humanoid robots inevitably brings strong emotions, and one of the most immediate is fear. People have a legitimate concern about robots taking jobs. For generations, steady work has anchored families and communities. This anxiety is not abstract, it is personal. But technological change is also about transformation and opportunity. New roles emerge: technicians to maintain robots, software engineers to program tasks, data analysts to optimize performance, trainers to guide collaboration. A robot that cleans waste, handles hazardous materials, or works in extreme environments improves human well-being. Technology is neutral, implementation is a choice. With planning from companies, supportive policies, and open dialogue, we can augment people, not replace them. The image of a robot doing a tedious, unsafe job can be hopeful if it frees someone to learn, create, and live healthier lives. The journey from a single prototype to mass production is monumental, and the actuator order is one piece of a vast puzzle. Every component, from the tiniest screw to the most complex sensor, must arrive at the right place at the right time. Tesla must build lines that assemble hundreds of intricate parts with precision and achieve high yields for profitability. Unlike caged robots, humanoids work close to people. They need 360-degree perception, predictive motion, instant avoidance, and strict force limits. Economies of scale matter. Massive actuator orders can drive down costs of one of the most expensive components. If Tesla streamlines the bill of materials and manufacturing flow, Optimus can reach a price that many industries cannot ignore. The road is long and difficult, but this leak signals that Tesla is not just on that road, it is accelerating down it. In the end, the leaked actuator order does more than hint at a schedule. It marks a potential turning point in modern industry, moving humanoids from speculative fiction and labs into supply chains and timelines. While it does not guarantee success, it is strong evidence that Tesla is making a serious, well-funded, logistically planned attempt to be first to mass-produce a viable humanoid. This single piece of data shifts the question from if to how soon, with Q1 2026 as the industry's marker. Early deployments will likely be in Tesla's own factories and warehouses, proving uptime, versatility, and safety alongside people. This moment is about people and the future of work, education, job training, the safety net, and redesigning jobs to be safer and more creative. A simple purchase order tells a grand story of ambition, innovation, and impending change. Q1 2026 may open a new chapter in automation, and its next pages will be written on the factory floors.